in hyper-converged stuff and ways to see through it. I'm Max Kalametsev, your host for today, and just to remind you, this event is recorded and we are going to put it on YouTube after the event, so you can send it to your friends, watch it afterwards. Basically, our every Thursday event is a more relaxed and more laid-back version of our webinars. We do not get that serious atmosphere. We try not to get into all technical detail, just the general ideas and concepts, or solve some general problems, not getting into tiny things, only during Q&A session. And here's a quick agenda for our today's event. That's about me, not interesting. So first we'll look at mixing shared storage and hypervisor in one server, how we came to that hyper-converged model and what it brought us. Then we'll see which bluffs can there be with hyper-converged platforms and current offerings on the market. And then I'll tell you about fail-play hyper-convergence. Your game, your rules. And it's your IT environment, so you need to manage it and you need to control it on 100%. And of course a Q&A session. I'll be able to answer all the questions you may have. Now, a bit more about Bluff and how it came into play here. So originally, most infrastructures around the globe looked like this. There was a centralized SAN, there were some hypervisor servers with certain hypervisor running on it, and VMs running your applications. So looks like a bit of an inverted pyramid for me. And it actually is, because should one resource, in our case SAN or SAN switch, fail, we lose the entire server farm. Or they're just useless because there is no storage and you cannot access your applications or your virtual machines. But now, with hyperconvergence, we see a lot changing in this picture. If we unify our storage layer and our compute layer, we get a single resource pool which is much more reliable and which is essentially unified, because every server is now a component which is expandable and there is no proprietary part of the puzzle anymore, which was the SAN. Now every participating server acts as both compute power and storage resource, and they're of course doing replication between each other to provide us some redundancy. And back in 2011, StarWind first announced their hyper-converged offering, which was native SAN for Hyper-V. That was a few years before VMware announced this as the new platform of choice for all the other hypervisors, and the whole story began. And since that time, there were a lot of vendors appearing in the market and saying, hey, we do hyper-converged platform. You can get everything in one box if you buy our solution. And in the new market, there is often a lot of buzzwording, marketing activity, and of course here comes the bluff, here comes the snake oil, as John Toigo mentioned yesterday on his webinar, Avoiding Snake Oil in Software-Defined Storage in the Hyper-Converged Platforms. So what are the typical bluffs you get from the hyper-converged platform vendors? First one is I like the most. I've seen this acronym on Spiceworks. I really liked it, so I decided to put it in the webinar. Whoever invented it is a good guy, and thanks for sharing that term with us. So just put in another node. The idea is simple. You go for a hyper-converged platform, you solve all the issues you had previously, like lack of provisioning, flexibility, complexity of management, complexity of scale out and scale up. Now you have a hyper-converged platform, and let's say you need a little more horsepower. So you still have storage, but you need to run few more virtual machines, but your CPU does not allow you to do that. And the answer you'll get from your hyper-converged platform vendor is mostly just put in another node. And that's their revenue, and that's the Bluff. Initially, you got an idea that this is a really scalable platform, and you can easily add servers on the go, but then it's time to realize that you can only add servers. If you want to get more flexibility on per server level, no. It's only add another node. Then another popular bluff is our configurations are really scalable, but to start you need to buy at least 3 servers. And actually we recommend 4 or even 6 to start with, because that distributes our load better. Or we have some storage code which is not written in-house, so we only support this and we cannot make it smaller. Now that's all good and nice, and it may be okay if you need 3 servers to run all your virtual machines. But a lot of SMBs, a lot of remote offices require much less than 3 servers. They could get away with 1 server, but nowadays quality of service depends much more on uptime. And in the remote locations and branch offices, uptime is critical because that's the place where you meet the customer. So it's a good idea to get them some reliable equipment with minimum number of servers involved, which is easy to manage. And most of the hyper-converged platform vendors cannot do that because they offer some restaurant chain to get 3 servers in all their offices, and that's usually multiplied by hundreds or by thousands. So if we're talking about, let's say 100, it's $1 million. If we take 1 server out and get highly available configuration with less servers, that's already minus at least 33% from the configuration, which is not bad at all, and it can be a huge decision maker in the purchasing process. Then another bluff is the hardware vendor lock-in. Basically, you get a hyper-converged platform, you start using it, you're happy with it, but then at a certain point you see, oh, there is some new PCIe SSD card. I'd really like to use those to speed up my servers. And you contact your hyper-converged platform vendor and they say, oh, no, you can only use the ones we provide. You cannot put any other hardware in. Or you want to expand your existing platform with, let's say, an additional server which is bigger and would run some specific application which no other server from their hyper-converged platform vendor can handle. And technically you cannot do that. So you have to stick with one brand, and there is no way for you to do a step left or right from the configurations and servers provided by the vendor. And this also has one side effect which starts affecting these configurations from the very beginning. Most of the hyper-converged platforms say that you have to demolish and decommission anything you had before, because that will not play along with our new platform. Otherwise, you'll have islands of resources on your old platform and on your new hyper-converged platform. So there is no way to unify them smoothly. And another bluff which kind of ties with the rest is the hardware configuration lock-in. So you cannot really choose which nodes you're adding to the configuration. You can only choose how many nodes. Okay, how much horsepower do I need? Okay, that equals 2 more CPUs. Okay, in my case that only equals 2 more nodes because I cannot add 2 more CPUs to the configuration. I need 1 more terabyte of storage. Okay, I have to add another node because I cannot add just another terabyte of storage to my configuration. Even if you have 4 to 5 servers, you could easily add 5 hard drives and just expand the storage on your existing servers. But with most hyper-converged platforms, that's a no-go. So what makes this bluff really a bluff? The fact that there is a fair player which says you don't have these problems anymore and you can really solve them like this. So fair play hyperconvergence. Your IT environment, your game, your rules. So the idea is that with StarWind Virtual SAN, you are not tied to any of the bluffs described on the previous slide. First of all, StarWind Virtual SAN does not prevent you from scaling up or scaling out. It gives you the flexibility to do so. So let's say you have 2 servers acting in your production environment, running your applications, and you need more storage. In this case, you just add more disks to the servers. You don't necessarily need to add a 3rd server or a 4th server to get more storage, because this will be a waste of compute power. You don't need to add another node. You may just add some more storage. And of course, if you want to add more horsepower, you can add another node. If you need more RAM, you can scale up existing boxes by adding more RAM. So there is nothing bad in it. So there is some, not really some, there is much more flexibility in just one bullet point here. Then the problem I mentioned earlier, the remote offices, the branch offices, the SMBs, a lot of them don't need 3 servers to start with. They may get away with just 1 server and reliable backup, but getting highly available is in trend nowadays, because few minutes of downtime can cost you 10 negative Facebook reviews and kill the business when it's just starting. And it can cripple big business because someone says, okay, I couldn't have lunch today in my favorite restaurant chain because there was something with the billing process and I had no cash on me. So I just went to another restaurant. And all that because they had 1 server and a backup unit. So if they were highly available, this couldn't have happened. Then, forget about vendor lock-in with StarWind Virtual SAN. You have the HCL of your hypervisor, which may limit you a little, but HCLs are usually quite broad, and you can use any hardware you want. StarWind Virtual SAN runs on any industry standard server and is not tied to any particular configuration. It doesn't require SSDs in the server to operate. It only requires spindles and RAM, and if you want to use SSDs, it's okay if you add them. So it's not mandatory to have them even if you don't need them. And of course, with StarWind Virtual SAN, you can forget about configuration lock-in. The nodes you use for StarWind Virtual SAN can be configured any way you want. You can have any number of CPUs. You can have up to 1.5 terabytes of RAM. If modern servers support it, you can have as many flash drives as you want. You can have as many spindle drives as you want. And of course, with every node you add, you can modify this number to balance your environment and make sure you use the most of it. So make the right choice and don't get on the hook of hyper-converged bluff, because first it may be appealing, but then when you get to managing it and scaling it, it can be a big pain in the back. Now it's time for your questions. Feel free to use questions and answers box in the GoToMeeting toolbar, and I'll read your questions out loud and make sure I get the answers for you. Okay, Eugene is asking us, any hardware you want sounds good, but keep in mind to have same CPU versions to avoid reduced performance due to a low migration to different CPU versions enabled option. Yep, of course. So there is some common sense, and there is any hardware you want. So you can definitely have an Intel platform, but if you then decide to mix it with AMD platform, you'll have some migration issues. So that's just common sense, and that's different architectures. But from the storage perspective, from the server power perspective, these things can be mixed. Okay, question from Andrew. How is StarWind installed? StarWind is installed as a native application inside Windows 2012 R2 and as a virtual machine inside any other hypervisor. Then it takes ownership of the local storage resources and RAM resources and converts your local storage into highly available shared storage resource. Okay, any more questions? Come on, we have plenty of attendees today. And suddenly people are becoming more attentive. Okay, question, how is StarWind Virtual SAN comparing to VMware Virtual SAN? So first of all, we're trying to compare block storage to object storage here, but technically both products do the same. They simplify your life with the hypervisor. So the main difference between StarWind and VMware Virtual SAN would be StarWind requiring just 2 servers to operate, not requiring any SSDs to operate, and leveraging RAM as caching to operate. While VMware Virtual SAN requires configuration with certain number of SSDs, certain number of spindles, and has a quite narrow HCL at this point. Then, okay, a question from Robert. Do I need to mirror SSD level 2 cache? How large should I size the SSD cache? The rule of thumb for SSD cache sizing is 10%, but depending on the working set and your particular workload, this size may vary. Most of the vendors use 10% as base number, and if that's not sufficient, I guess we need to benchmark your particular workload and determine the working set to make sure the SSD cache is properly sized. Okay, question from Eugene. Will the StarWind LSFS make extra payload to storage subsystem of server, slowing overall speed down? Onboard RAID and disks usually less power than SAN systems. The idea behind StarWind LSFS is to unload the storage subsystem. So the design implies that StarWind LSFS writes to the disk sequential only, and it is not doing any random writes to the storage. And it's also using big blocks, so it's not doing substripe writes, which makes it possible to use RAID 5 and RAID 50 as primary production storage without loss of performance. So effectively, your write performance with any virtualized workload would be comparable to sequential write performance. So it's not just IOPS anymore. You can technically look at megs per second and then convert it into IOPS to see your actual write performance. And with that type of storage, reads are mostly random, so we speed them up using the SSD read caching, which is a good thing because SSD has minimal seek time, I would say even no seek time, and we also avoid writing much on SSD, so we keep them long living and healthy. Question from Robert. I missed whether SSD cache should be mirrored. What will happen if the SSD cache fails during SAN operation? Oh, sorry for that. So the SSD cache should be mirrored for now. We decide SSD cache failure as a potential storage issue, and in that case the SAN is temporarily blocked from operation and I/O is fetched from other SANs in the configuration. Okay, a question from Eugene. Does the StarWind provide pass-through trim unmapped disk subsystem to reduce the SSD wear out? Indeed, we do. However, there are certain technical issues with SSDs and trim unmap. There are multiple threads on the web describing it. So Windows, let me recall that. It was something like, does the SSD support deterministic trim command? As far as I remember. So there were some issues with low-end SSDs supporting trim unmap in Windows. That's the only limitation. From StarWind side, we pass through all the trim unmap commands to the backend storage with no problem. Question from Carlos. Is it using any of Microsoft Storage Pool's resources, APIs, as it is installed in 2012? Probably is a prerequisite, right, but any GOTAs for a mass install? No, StarWind does not use any of Microsoft Storage Pool's resources or APIs. The only thing we used previously from Microsoft was the iSCSI initiator to cross-connect our servers in the environment. Right now we use our own initiator, which is hard-coded inside StarWind to connect between our servers. And moreover, we provide some additional drivers for Windows which support passing through the information you write to StarWind, bypassing the entire TCP stack. So let's say you have two Hyper-V servers running some virtual machines and running StarWind on it. If they used a dedicated SAN, they would trigger TCP traffic, which is then converted into storage traffic on the SAN. While with StarWind, the I/O goes directly into RAM, bypassing the entire TCP stack, and from RAM it is then transferred to the disks directly. So the I/O path is much shorter with StarWind hyper-converged configuration, and the latency is much smaller. Okay, one more question regarding LSFS. Do I understand it correctly that it will need 3 times or better 4 times more disk capacity than provisioned to guest virtual machines to keep it running smoothly? Keep enough free space for sequential write. It is correct. StarWind needs 2.5 to 3 times more storage for LSFS, but keep in mind this is nearline SAS storage, and this doesn't need to be 15K SAS storage. So basically, it's behaving like any other log structured file system. Let's say NetApp does it, and even NTFS does it. If you write to NTFS with lots of small random writes, at certain point you'll see that after, let's say, 150 to 200 megs written, suddenly array responds with I cannot write command. It will think the disk is full, while you understand that you've actually written much less than provisioned on your hard drive. So it's same with LSFS. The only difference is that with StarWind, everything is open, so you actually see these files and you see these files growing. And with most of the hardware vendors, this is something you'll never see because there is a closed box which doesn't report to you how many disks it has and how much storage it actually uses. It only gives you a dashboard of how much storage you've got allocated and how much more you can allocate. Okay, I don't see any other questions coming in, so we'll, okay. Question from you. One more question from Eugene. Do I need to play maintenance for LSFS to optimize data allocation? You don't really need to plan maintenance for that. StarWind does data defragmentation on the fly as soon as it sees that your I/O has dropped, or if there is a critical situation and you have something like 30% of disk space left, StarWind will automatically throttle your traffic and start doing the defragmentation faster. And there is, of course, a mandatory defragmentation button included in the StarWind Management Console. So you can force defragmentation to run if you feel you'll be doing over-provisioning with your configuration really soon. But if you're within the limits, if you have provisioned 1/3 of your physical storage capacity, you're in good hands, and there should be no issues with defragmentation need for your system. One more question. ODX, is it supported? Yes, ODX is currently supported, and we'll be doing an ODX and VAI dedicated event in, I think in 1 week, on 21st of April. Aidan Finn and myself will do a webinar to announce these features as supported with StarWind. Okay, I guess that was all for the questions today. Thank you for attending our event. I hope it was interesting for you and you learned something new. And should you have any more questions, feel free to drop an email to any of the addresses provided on the screen. Thank you so much and have a great day.